Hello, good morning, everyone. Welcome. Okay, today, we have about 175 students watching. Very good, thank you. Good morning and welcome to all for the live session on Pspm SK015 paper preparation. So today with me, it's Dr. Yvonne and Madam Amiza. Okay, we will be presenting to you on the exam format as well as tips on each chapter and give you special insights on how you can actually ace the paper probably next week exam, right? Okay, so the session is going to start very soon and we are going to start off with Madam Amiza. She's going to brief you on the exam format as well as she's going to give you insights on chapter 1 and chapter 2, how to answer questions and how are the sample questions, what are the keywords that you have to look out for. And the session will be then followed by me. I'll be presenting to you chapter 4 and chapter 5, and the final part for today's session will be done by Dr. Yvonne. She will be giving insights on chapter 6 and chapter 7 and also her concluding remarks. Okay, so without further ado, let's begin. So I'm going to invite Madam Amiza to start sharing, and hope it will be a very good session for all of you to benefit. Yeah, okay, so let's begin.
Okay, Assalamualaikum and good morning, students. Thank you for joining us today. I'm having a technical problem today, so that's why you cannot see me. Okay, can you see my slide? Oh, of course you cannot answer, kan? Okay. Alright, so today I'm going to share with you how the techniques on how to answer questions in your final exam paper, the format of the exam paper, and also we are going to discuss on chapter 1 and chapter 2, the common mistakes and also the steps on how to write the answer for chapter 1 and chapter 2. Okay, so let's begin with, okay, wait. Okay, sorry. Wait, I'm having a technical problem here. I cannot move to next slide. All right. Okay, so during the examination, what you should do is, number one, you have to read the question carefully. Okay, then when you want to start writing the new question, please write the new question on a new page. Okay, and after that, you need to show step-by-step calculation when required by writing the formula and substitute all the values. Okay, and for me, I think it is very important for you to conquer chapter 1, because if you can answer questions in chapter 1, the first question, then it will motivate you to do or to answer the next questions. Okay, and also during the examination, before the final answer, when you do the calculation, before the final answer, make sure you take 4 decimal places or until three significant figure. Okay, 4 decimal places or three significant figure. Wait, okay, three significant figure. Okay, for example, 2.3235 is 4 decimal places, 0.2464 is 4 decimal places, and 0.0, okay, wait, 0.00222 is three significant figures. Okay, if you get more than 10 after the decimal point, okay, my suggestion is you have to convert to this standard form. Okay, you can write, for example, you can write 2.22 exponent -3. Okay, that one is for before the final answer. Okay, before the final answer also you have to write the unit. Okay, for example, the question is asking for molarity. Okay, but to find the molarity, we need to calculate the number of mole of the solid first. Okay, so when you get the number of mole of the solid, you need to write the unit also. Then only you will get 1 mark. And then for the final answer, you have to write in 2 decimal places. For example, 2.32 or 0.25. Okay, and after that, you need to check the unit. Okay, check the unit, because some questions we need to write the unit, but some questions, some answer, we don't have to write the unit. So it depends. Okay, and then after that, recheck your calculation and answer. Okay, we have two types of question. One is with 1 mark, the other one is more than 1 mark. Okay, for example, if the question is asking to state or name, usually it is 1 mark only. Okay, if the question is explain, discuss, predict, means it is more than 1 mark, meaning that we have to explain. Okay, explain meaning that you have to explain in words, in sentence, or you can calculate to prove. Okay, and then when explaining, include all the key facts. Okay, we can write in point form but not in short form. Okay, you also can construct table to show compare and contrast. Okay, to compare and contrast. All right. Okay, so this is our format of SK015, the final exam paper. Okay, question 1 is from chapter 1. Okay, 21 marks. Okay, for 21 marks question, okay, you can take the suggestion time. The suggested time is less than 30 minutes. Okay, it is between 28 or 29 minutes to answer question number 1. Okay, that's why I told you earlier that it is important for you to conquer chapter 1, because if you can answer chapter 1, then you have the motivation. Okay, you have the motivation, you have the confidence to answer next questions. Okay, and then for questions 2 is from chapter 2, atomic structure. Okay, and the mark is 10 marks, so you can take less than 15 minutes. Okay, for question 3 is from chapter 4, the chemical bonding, 17 marks. Okay, and you can take less than 25 minutes. Question 4 is from chapter 5, states of matter, 9 marks. Question 5 is from chapter 6, chemical equilibrium, both 9 marks. Okay, so the suggested time is less than 12 minutes. Okay, the last question is from chapter 7. Okay, 14 marks, so you can take less than 20 minutes to answer this question. Okay, so after that, you will left with about 5 to 10 minutes to recheck your calculation. Yeah, all right. Okay, now let's discuss chapter 1. Okay, let's discuss some questions and also some techniques to answer questions on this chapter. Okay, for example, from 1.1. Okay, let's wait for my slide. All right. Okay, so let's see subtopic 1.1, atoms and molecules. Okay, for example, let's say the question is asking to calculate relative atomic mass. Okay, relative atomic mass. So usually we need to calculate the average atomic mass first, but it also depends on the questions. Okay, you have to remember that the average atomic mass is the summation of chemi over summation of key, and it has unit. The unit is AMU. Okay, but for relative atomic mass, it does not have unit. Okay, because we have same unit top and bottom, so that's why we can cancel out. That's why it has no unit. Okay, when you write this formula, make sure you write the full sentence of the title, average atomic mass. Okay, you cannot suddenly you write equals to summation chemi over summation key. You won't get mark for formula if you just write the formula without the title. Okay, that one is for 1.1, relative atomic mass and also molecular mass. Okay, let's look at question from next subtopic, that is mole concept. Okay, it takes time to show my slide. All right. Okay, for example, we have empirical formula questions. Okay, for example, here the carbon you get the mole ratio is 1, hydrogen you get 1.33, oxygen you get 1. Okay, then you write the empirical formula is C1H1, oxygen also 1. Okay, but actually it is the hydrogen is 1.33. Okay, meaning that you cannot round off to 1. Wrong. Okay, chemical formulas are written with whole numbers, so beware of the rounding off. So you can try an error. If you get 1.33, you cannot round off to you cannot round off to 1. Okay, the same goes, for example, you get 1.7, so you cannot round off to 2, cannot. So you can do trial and error method. For example, okay, let's say here now we have 1.33. So if 1.33 times 1 is still 1.33, how to get whole number? 1.33 times 2, 2.66, not a whole number. But when 1.33 times 3, it is 3.99, or um, uh, apa? Lebih kurang. Okay, more or less the same with 4. Okay, so that's why, okay, when the hydrogen times with 3, the other two, the carbon and the oxygen also, you have to times with 3. So that empirical formula, you will get C3H4O, or oxygen 3. Okay, this one is the correct way to answer. Okay, now let's look at concentration measurement. Okay, concentration measurement, you have to we have 5 formulas. Okay, we have 5 formulas for concentration, and you have to memorize all the formulas in concentration. We have molarity, we have molality, percentage by mass, percentage by volume, and also mole fraction. So when you get question on concentration measurement, what you should do first is you need to identify from the question. You need to identify which one is the solid, which one is the solvent, and which one is the solution. Okay, for the solvent, okay, usually the solvent is water. Okay, unless it is stated differently in the question. Okay, but usually we can assume that the solvent is water. For example, here we have the solid is sodium hydroxide, the solvent is water, and the solution is sodium hydroxide solution. Okay, you have to identify that first. Okay, and we have 2 formulas from the 5 formulas of concentration. Okay, 2 formulas, we have to write the unit. Okay, and they are molarity and molality. Okay, okay. For molarity, okay, meaning that when you write the formula, okay, when you write the formula during your exam for molarity, okay, from the prefix mole, so we know that it is moles of solid over volume of solution, compulsory to write in liter. Okay, volume of solution, even though it's still in the formula, you have to write liter here in the formula. Same goes for molality. Okay, look at the prefixes is molality, mole. So that's why in the formula we have moles of solid divide with mass of solvent. Okay, the mass of solvent is in unit kilogram. Okay, also compulsory to be written in your formula. Okay, so let's try a question. Okay, tak tahulah kenapa it takes time to show my slide dekat YouTube tu. Okay, okay. Now please write please write pula. Dah terbiasa kan cik suruh tulis je. Okay, please read the question. The density of solution A is given 1.25 gram per mil, while the percentage by mass is 32%. Calculate the molarity of the solution. Okay, calculate the molarity of the solution. So when you get this kind of question, your first step is, okay, before you write all the formulas and so on, your first step is you have to identify which one is the solute, which one is the solvent, and which one is the solution. Okay, and then after that, you have to write all the information given. Okay, write all the information given in formula form. Okay, for example, okay, given is density of the solution. Okay, density of the solution. So you can write density of the solution is equals to mass of solution over volume of solution. Okay, since now we have 3S, we have solution. Okay, we have solute, and also we have solvent, 3S. So sometimes it becomes confusing. Okay, it becomes confusing because we have 3S. So that's why in your formula, only solution, you write solution. Okay, if solute, you write what is the what is the solute given in the question. For example, if the solute is A, so you can write mass A like this. Okay, you can write mass A. Okay, and then for solvent, you can write water, H2O. You don't write solvent, you write water. Okay, okay, for this question, okay, density of the solution is mass of solution divided with volume of solution. Okay, you write the formula. Okay, you write the formula and also the information 1.25 gram per mil. Percentage by mass is mass A over mass of solution times 100 equals to 32%. Okay, then after you write the information, step 2 is you write the question in formula form. Okay, the question is molarity. So you write moles of A over volume of solution in unit liter. Okay, then okay, you find out one by one. Okay, to calculate molarity, we need number of moles of A. So is it given from in the question? No, moles is not given. Is the mass of A given? Also not given. So meaning that since mass of A also is not given, so meaning that this question is lack of information. If the question is lack of information, means we have to assume. Okay, and remember that we can only assume if we are lack of information. If all the informations are given, then you cannot assume. If you still assume, even though we have enough information, then it will be wrong. Okay, how to get moles of A? Okay, how to assume? What can we assume? Okay, usually we can assume mass of solution or volume of solution or mass of solvent. One only you can assume. Okay, for example here, to get moles of A. How to get moles of A? To get moles of A, of course we need mass of A. So that's why to get mass of A, we can assume mass of solution. Okay, so to make your life easier, what is the value of mass of solution that you can assume? Of course, okay, to make our life easier, we can assume mass of solution as 100 gram. And whatever you assume, you have to write. So that one mass of solution is 100 gram. So we can cancel with this 100. So you can get mass of A is 32 gram. Okay, mass of A is 32 gram. This is one method, or an alternative method. Okay, or an alternative method, we also can assume volume of solution. Okay, for alternative method, we also can assume volume of solution, but you have to choose one only. Either you want to assume mass of solution or volume of solution. Okay, then next one is stoichiometry. Okay, you still remember what you have learned in stoichiometry? Okay, in stoichiometry, we learn on limiting reactant, right? Okay, we learn on limiting reactant. Okay, so I hope you already understand, you already remember, you have memorized the definition of limiting reactant. Okay, so let's try a question on limiting reactant. Okay, how to get a full marks? Okay, how to get a full marks when determining the limiting reactant? Alright, so we have a question here. Okay, we have aluminium reacted with iron oxide, determining the limiting reactant. Okay, so the maximum marks given to determine the limiting reactant is 6 marks, meaning that you can get a maximum of 6 marks only to find the limiting reactant. Okay, so how? The first step is you need to calculate the number of moles of both reactants. Okay, number of moles of both reactants, because now from the name itself, limiting reactants. So that's why we know that only the reactants, okay, only these two reactants are possible to become the limiting reactant. Products, impossible to become the limiting reactant. Okay, so that's why we calculate number of mole of aluminium and also iron oxide. So you will get 1 mark each. Okay, after that, you can compare the stoichiometry between aluminium and iron oxide. Okay, you can from the balance equation, 2 mole aluminium equivalent to 1 mole iron oxide. So if we have 4.59 to 6 mole of aluminium, so we need this amount of iron oxide. Okay, so here for your for your stoichiometry, you will get 1 mark. Okay, make sure in your stoichiometry you write the unit. Okay, without the unit, the mole here, then you won't get any mark. Okay, 2 mole aluminium, 1 mole, 4.5 mole, mesti ada unit Okay, so the stoichiometry with correct unit, with complete with unit, 1 mark. Okay, the answer, number of mole of iron oxide needed, 1 mark. And then when you write this statement, okay, when you write this statement, number of mole needed, you compare number of mole needed with number of mole available. Okay, then you have to determine which one is the limiting reactant. Okay, when you compare mole needed with mole available, you'll get 1 mark this sentence. And when you write the conclusion, you will get 1 more mark. So now aluminium is the limiting reactant. Aluminium is the boss. Okay, why aluminium is the boss? Because since aluminium is the limiting reactant, it will limit the amount of the product form, and it will also determine the amount of excess reactant that will react. So that's why the limiting reactant is always the boss. Okay, remember. Okay, so beside that, how can we make sure that our our decision is correct? How can we make sure that our limiting reactant is correct? Okay, because once we get the limiting reactant, the rest of the questions after that is based on the limiting reactant. So that's why it is very important to get the correct limiting reactant. So how to check? Okay, how to check whether we get the correct or not limiting reactant? So for example, here, okay, we can use a trick. The trick is very simple. You don't have to calculate. Actually, you don't have to press your calculator. You don't have to use your calculator. Just congak-congak in your mind. Yeah. Okay. For example, mole of aluminium available just now is this value. So you divide with 2, you get lebih kurang 2.3 moles. Okay. Iron oxide divide with 1. So how do I get 2 and 1 here? It is from the stoichiometric coefficient. Okay, 2 aluminium, so that's why divide 2. 1 iron oxide, so that's why divide 1. Okay, then which one is the smallest value? The smallest value is 2.3, right? Okay, so that's why aluminium is the limiting reactant. But please don't use this trick in your working. You won't get any mark. You will only get 1 mark for the conclusion. Other 5 marks, lose. Okay, habis dah 5 markah. So when you want to determine the limiting reactant, use the working that I teach you just now, but not this one. This one is just to check. Boleh congak-congak dalam kepala sahaja. Okay. Okay, next question. Okay, next question is, okay, calculate the amount of the product formed. Okay, calculate the amount of product. The product is aluminium oxide formed. Okay, so now we already know that aluminium is the limiting reactant. So how to determine the amount of product formed? It depends on the limiting reactant or it depends on the excess reactant. Of course, the amount of product formed depends on the limiting reactant because the limiting reactant is the boss. Kan? Kenapa nak guna excess to compare with the product? Okay? Kenapa penat-penat tadi kita cari limiting reactant. Lepas tu nak ambil orang lain pula to compare with product. Salah kan? Itu pun satu common mistake. Sebab mungkin kurang faham apa maksudnya limiting reactant. Okay, so since aluminium is the limiting reactant, so that's why we compare the limiting reactant, the boss, with the product, aluminium oxide. Okay, you get the number of moles of the product form, and then you times with molar mass, then you will get the mass of the product formed. Okay, so remember to calculate the amount of the product form, always use the limiting reactant. Okay. Okay, we have to write the stoichiometry like this. Okay, before you calculate the value, the stoichiometry here, you will get 1 mark. Lama betul nak tunggu dia pindah slide ni. Okay, now let's discuss. Okay, we have done with chapter 1. Now let's discuss about chapter 2. Okay, chapter 2. Okay, for chapter 2, if you still remember, it is divided into two. Okay, the first part is when you learn about the Bohr's atomic model. Okay, the old theory of atomic structure is called as Bohr's atomic model, while the second part is quantum mechanical modern, the modern theory that explain how the structure of an atom looks like. Where can we find the electron? So that is quantum mechanical model, the modern theory. Okay, example here. Okay, example on Bohr's atomic model, we have a line spectrum. Okay, figure shows the Balmer series of hydrogen emission spectrum. We have line T, S, and R, S, and T. Calculate the energy corresponding to line S. Okay, do you know that this one is Balmer, meaning that all the electrons they fall to n equals to 2. Okay, but here we have to find out which one is the first line. Okay, so which one is the first line, even though they label starting from this line, but actually the first line is here. Okay, the one at your far right is the first line. Kita tengok the gap between the lines. Which gap between the lines is the biggest gap? Ni kan, ni paling besar kita tengok gap. So this one is the first line. So the first line is occurred or is produced when the electron falls from 3 to 2. Okay, line T is produced when electron falls from 4 to 2, while line S is formed when electron falls from 5 to 2. Okay, so remember, okay, line S is formed when electron makes a transition from energy level number 5 to energy level number 2. Then how to calculate the energy released? Okay, how to calculate the energy released? Of course, we have formula. Okay, delta E is equals to RH 1 over N initial square minus 1 over N final square. Okay, we have formula. You just have to substitute the values. The initial energy level now is 5. Okay, initial energy level is 5, while the final energy level is 2. Then when you calculate, you will get negative. Okay, negative value. Why you get negative value? Because energy is released. Electrons fall from a higher level to a lower level. Okay, and don't forget to write the unit. The unit is in joule. Okay, and also be careful here. Okay, because the list of constant, if you refer to the list of constant, we have two Rydberg constant values. Okay, one is in unit joule, one more is in unit per meter. So to calculate delta E, we have to use, delta E is energy, right? So that's why we have to use the constant in unit joule. Okay, if you want to calculate wavelength, panjang gelombang, panjang, kan, wavelength. So that's why we have to use a constant. Okay, our Rayburn constant with unit per meter. All right. Okay. Next question. Okay, the first question, calculate energy for line S. Okay, next question is draw the electronic transition of line R, S, and T on the energy level diagrams. Okay, so here we have to construct the energy level diagram. Okay, so to construct the energy level diagram, the y-axis we have to write the energy. Okay, the energy, while the x-axis, okay, the x-axis we have to write the level, the energy level. Okay, it's up to you. Actually, here you can start the lowest energy level. Actually, you can start with n equals to 1. But since it is Balmer, if you want to start with n equals to 2 pun boleh. Okay, so okay, if you refer to the previous question, okay, T is formed when electron falls from n equals to 4 to n equals to 2. S is from 5 to 2, while R is from N6 to N2. Okay, so you have to write the arrow pointing downward. Okay, arrow pointing downward because all the series, Balmer, Lyman, Paschen, all the 5 series, they occurred, they produced. Okay, we can see the light because electron falls back. Okay, so that's why the arrow is pointing down. Okay, let's try next question. Question number 2. Okay. An electron of a hydrogen atom is excited to energy level n equals to 6 and drops to a lower energy level to form a line in the Paschen series. Calculate the energy of the electron at the excited state. Okay, energy of the electron at excited state. Okay, meaning that now the question is asking about the electron when it is not moving to anywhere. Kan, energy of the electron when it is at excited state, not the energy of electron when it falls to n equals to 4 ke, bukan. Not the energy of the electrons when it jump to higher energy level, no. But this one is energy of the electron at the excited state before it drops. Okay, so Paschen series is n equals to what? Paschen series mean n equals to 3, meaning that from the electron is from 6 falls to n equals to 3. Betul ke? Leman bangun pagi, breakfast pagi. Betul lah tu. Paschen is n equals to 3. So that's why we have to use this formula. Okay, be very careful with the question. Is the question asking for energy or different in energy? So here, okay, we have to use the formula. Then you can insert the values. And here, n is 6. Then you'll get the value. Alright. Okay. Okay, saya sempat baca live chat sini. Y-axis just now for the energy level diagram, the y-axis should label as E, correct? Thank you, Jude Devaraj. Okay, thank you very much. It's correct. Kan? Baru perasan sebenarnya masa saya buka slide tu. Oh, baru perasan delta E, kan? Okay, actually it is energy, not delta E. Okay, thank you for that. Alright. Okay, then let's look at next question, next example. Okay. For some questions, from the question, okay, from the grammar of the question, kan banyak ke sikit ke, from the grammar of the questions, we can identify. For example, the first question state all the possible values. Values, we have S. Okay, meaning that we can have more than one value for N, L, M, and S. Okay, the question is not asking for set of quantum numbers. No. Okay. All right. Okay, so state all the possible values. So 4D orbital, so n equals to 4, L is equals to 2. So since L is equals to 2, so M we can have 5 values. And else also we can have 2 values. So it is for M and S, it is compulsory to show the positive and the negative sign. Okay. Okay, and then next question. The question is write a set of quantum numbers for an electron. Okay, write a set of quantum numbers for an electron. Okay, a set of quantum numbers is an LMS, and set of quantum numbers is just like our IC number. Okay, one IC number is unique for only one person. Okay, we don't share IC number, betul tak? The same goes for electron. One set of quantum numbers indicates for one electron saja. Okay, now the question is asking for an electron, sebiji electron in 4D. Okay, so that's why n is equals to 4 because 4D. Okay, L is equals to 2 because d orbital. For value of m, okay, value of m, you have 5 options. Negative 2, negative 1, 0, positive 1, positive 2. But you can only write one answer. Tak boleh letak banyak-banyak answer kan. Sebab macam nombor IC kita, nombor tengah kita tu kan, nombor IC yang tengah tu, kan kalau lahir dekat Perak 38. Kalau lahir dekat Selangor tulis nombor lain pula. Saya tak ingat nombor apa kan. Nombor lain pula. Lahir kat Kedah nombor lain pula. Mana boleh tulis semua nombor. Kan? Okay, sama juga macam IC number untuk elektron. IC number for electron is called as set of quantum numbers. Okay, I think this one, okay, next question. I think this next question is the last question. Okay, on how to write the electronic configuration. Okay, electronic configuration, we have two, SPDF notation and also orbital diagram. Okay, SPDF notation and also orbital diagram. Okay, sorry lambat pula dia nak keluar ni. Alright. Okay, the question is an atom Y has 25 protons. Write SPDF notation and orbital diagram for ion Y2 plus. Okay, so if you want to write the ion SPDF notation for the ion, we need to write SPDF notation for the atom first, compulsory. Okay, write for the atom first, then only you write for ion. Okay, so from the atom here, we know that 2 plus means we remove 2 electrons. So we remove the electrons from the outermost shell. Okay, so we remove from 4s. So that's why we end with 3d5. Okay, what happened? Okay, what happened if you directly write the SPDF notation for Y2 plus? You don't write atom Y first. Tak turun untuk atom. Terus Y2 plus. Macam mana awak buat? You buat macam ni, 25 minus 2 sebab dia tengok dia donate 2 electrons kan. 25 minus 2, 23. So you arrange the 23 electrons. So what will you get? You will get this wrong SPDF notation. So that's why it is important for you to write the SPDF notation for atom first, then only for the ion. Alright. Okay, and next one. Okay, itu salah dia kata kan. Okay, next one. Let's write the orbital diagram. Okay, we have a lot of new terms in this chapter. We have orbital diagram, we have the shape of orbital, and they are two different things. Orbital diagram, shape of orbital. Kita tengok what is orbital diagram. Lama betul nak tunggu slide ni dia berubah kan. Alright, okay, ada pun slide. Okay, so this is how to write the orbital diagram, not shape of orbital. Shape of orbital is dumbbell shape, spherical shape, clover leaf. That is shape of orbital, bentuk orbital. Okay, sometimes the question is like this. Draw the orbital diagram. Tapi sebab student tengok dia draw orbital diagram, draw tu, dia terus lukis bentuk-bentuk tu. Salah So to write the orbital diagram for Y2 plus, so this is how to write the orbital diagram. Make sure when we have degenerate orbitals, small space only between the orbitals, and big space when we have different orbital. 3s and 3p lain kan? So that's why we have big space between them. Okay, and one more thing, it is wrong if you write this way. 1s2 ada 2 ke atas, 2 ke atas, 5 ke atas ni example this one is wrong. Okay, so be very careful. Okay, so that's all from me. Okay, thank you very much. Let's proceed with Madam Vaishnavi. Will present on chapter 4 and chapter 5.
Okay, thank you so much, Madam Amiza. Right, very detailed explanation on the format as well as the time needed to answer each question, and also the answering techniques, especially for calculation questions. So the take-home message that I would say is that it is important to identify all the informations given in the question, and also make sure you write out the formulas. That's very important, and substitute in the correct value, as well as make sure you do a unit conversion if it's necessary, and also take note on the significant figures, significant values in your question. Okay, so make sure you are not rounding off your answers too early in the middle of the question. And final answer, make sure you are aware of the unit for your answers, right? So with that, I am going to continue with chapter 4 and chapter 5. Okay, so there we have it. All right. So if you have any questions, you can feel free to post on the chat box. Dr. Yvonne and Madam Amiza will respond to you, yeah, since I'm presenting. Okay, so let's begin with chapter 4, chemical bonding. So what are the commonly asked questions in this chapter? So as I look through past year questions, these are the keywords that have been given in questions. For example, state, define, write. You are also required to draw, sketch, show, which is followed by labeling. And also there has been questions on identifying, predict, and arrange. Compare contrast questions were also there. Some questions require you to determine, deduce, and mostly questions on explanation and giving reason, and finally question on description. Okay, so chapter 4, as you have seen in Madam Amiza's slide, it is one of the chapters with the highest weightage of mark. So the questions can be various. Okay, so let's look at the different type of questions and how you can actually answer them. So the first type, which is the state, write, and name, usually it's given 1 mark. So here I've given 2 examples on this type of questions, whereby the first one requires you to write the, sorry, give me a moment. Right, yeah, the laser point is up. So to write an electronic configuration of element A and B with proton number 12 and 17 respectively. So how are you going to write your answers in your exam sheet? So make sure, okay, to label A has an electronic configuration of such and B has an electronic configuration of such. Do not just write out answers, okay? Make sure you note A has such and B has such, right? So same goes to the second question. State the number of electron pairs around the central atom of ClF4 plus. So for this question, firstly, you have to draw the Lewis structure, although it's not required in the question. So as you can see from here, when the question requires you to state, you just don't state, you introduce your answers by saying electron pairs, 4 bonding pairs, and 1 lone pair for this particular structure over here, right? So you have to be very specific with your answers, although it's a state or a name or a right question. In order to get your full marks, it's better for you to write this way. Okay, note that what is asked in the question and answer accordingly. So the next type of question that we are going to go on to is the drawing and sketching. So each drawing and sketching that you do must be labeled. So for example, here it's given to be all possible Lewis draw all possible Lewis structures of nitrous oxide. So how are you going to answer this question? So there is actually 3 structures, and make sure to label your 3 structures. Okay, identify them by stating this is structure 1, structure 2, and structure 3. Okay. So how about the identify and predict questions? These kind of questions usually follow in the same question, meaning if you see the example for over here, the first part says show the formation of compound magnesium oxide using Lewis symbol and identify the type of bond. So here the take home note is that you must read your question fully until the end. So it is very tempting to actually read halfway. Okay, show the formation of compound and MgO using Lewis symbol, but most of the time, because you're rushing for time, you want to finish the paper fast, you tend to miss out on the second line. So tell yourself during exam that you have to read it fully, okay? Because usually these predicting and identify questions follow very closely in the same sentence. So how do you show this for this question? So this is an ionic bond formed between magnesium and oxygen. So make sure you have your arrows clearly indicated from the electrons on the magnesium going towards the empty space here on oxygen. So make sure the valence electrons are all shown, right? You have to be very specific. In drawings and sketchings, you have to be very specific and you have to label. That's the take-home message. Okay, so the type of bond, it is definitely encouraged that you state the type of bonding, dot dot, ionic bond. Okay, instead of just writing ionic bond, because this shows that you are actually answering the question. You are aware of what question is being asked to you. Okay, so moving on, the arrangement type question. Okay, so arrangement type question, it is highly recommended that you must use the correct symbol, meaning less than or more than symbol, to show items that are ascending or descending. Okay, so below your arrangement, kindly include an arrow Okay, and write the property that you are arranging. For example, increasing boiling point. And the next message is that include all item given in the question. Never miss out any item or a compound or an element that is given to you to arrange. So make sure you are including all the item in the question. And finally, arrangement question is usually followed by an explanation. So you must always be aware of that also. Read your question till the end. So here's an example. So as you can see, arrange the following compounds in order of increasing boiling point. And the question follows by saying, explain the difference in boiling point between hydrogen fluoride and hydrogen bromide. So here's the answer. So as you can see, I have used the symbols correctly, whereby they have set it to arrange by increasing boiling point. So I have sorry, the symbols are actually inversed. I'm so sorry about that mistake over here. The symbol is supposed to be inversed. Hydrogen fluoride has got the highest boiling point. So please take note, this is wrong. Okay, the symbol should be inversed. Okay, hydrogen bromide has got the lowest boiling point. Hydrogen fluoride has got the highest boiling point. So please take note, these are actually the common mistakes you do as students. Okay, I'm glad I made this mistake because these are the common mistakes that you do as well. Okay, so please be very, very careful in using these symbols over here. So as for explanation, as you can see over here, you can use point forms, but in your point forms, make sure you have complete sentences. Don't just state HF is higher than HBr. Okay, so what is higher in HF? The boiling point, okay, of HF is higher than HBr, and HF forms hydrogen bond between molecules. So have a complete sentence. Don't just state that HF forms hydrogen bond. Okay, and HBr weak van der Waals. Don't have hanging sentences. Make sure you complete your sentence and make sure you have a comparative writing. Okay, you don't have to use bombastic words. You can use simple connecting words to answer your question. It is very much sufficient. Okay. So let's go on to the next type of question, which would be the describing type of question under chapter 4, which carries the highest mark weightage. If you look through past year papers, these questions do carry the highest mark weightage. And this is an example here whereby you are required to show as well as describe the formation of bonds involving the overlapping of orbitals for the molecule IF4 plus. Okay, so first of all, how do you tackle this kind of questions? You have to start off with your Lewis structure. Okay, so don't forget your lone pairs. So then from your Lewis structure, you can go on by identifying the class of compound, electron pair arrangement, molecular geometry, okay, and the type of hybridization that is happening to the central atom over here. As you can see, these details were not highlighted in the question, but since it's a describing and a show type of question, you have to make sure you highlight all this in your answers. Another way to know that whether you have to include all this in your answers is to look at the marks given. Okay, if there is a big chunk of marks, fair enough, you have to include all this in your answer. Okay, so that looking at the marks before answering is a good indicator for you to answer your questions. All right, so the answer is not done here yet. We are continuing. Because since the question actually says, describe the formation of bonds involving the overlapping of orbitals, so you have to describe the hybridization. Okay, so you have an orbital diagram. As you know, this is just a recap for you. I'm sure you have done this many times in your tutorials. You have to do it for your central atom as well as for your terminal atom. And since it's charged molecule, make sure you calculate the formal charges pre-hand and note that the central atom actually carries a +1 charge. Okay, that means it has 1 electron less. And when you are drawing out your orbitals, okay, right, make sure to label them. This is another common mistake students do. They forget to label, okay, as 3s, 3p, 3d, or they label it wrongly. Some students, they label it as 2s because the most of the examples that you do in your tutorial was relating to 2s and 2p, so you tend to follow that. Please do not do that. Okay, make sure you know correctly that for iodine it's already in the third period. So make sure to label it as 3s, 3p, and 3d. These are all important things. Huh? And as for the excited state, okay, show the electrons correctly. Okay, make sure you're using a half-headed arrow. You're not just using a single line or a double-headed arrows. So that is very important. And as for the hybridized state, this kind of labeling is very important. Okay, sp3d. Okay, and the empty orbitals, you can leave it at the side and you can label them as empty 3d orbitals. Okay, so as you can see clearly over here, okay, 1 mark is given for each line, and it is important for you to identify the ground state, excited state, and the hybrid state. Okay, do not just write out this without the labeling of the state. That is also not advisable. Okay, so for the orbital diagram for the terminal atom, as you can see here, fluorine 2s and 2p clearly written, and that would give you a mark. All right. So let's continue to the last part of the question, whereby you have to show the formation of the bonding using orbital overlap. So that means you have to draw your hybridization diagram over here. Okay, drawing is not only enough, you have to continue with an explanation. Okay, you have practiced this also, so you have to state that the hybridization on the central atom, which is I plus, is sp3d. Okay, and what actually happens, this is the important part. So for sp3d orbital of I plus overlaps with for 2p orbital of fluorine to form 4 sigma bonds. So as you can see from the Lewis structure itself, you would be able to identify the bond between I and F was a single bond, so it is a sigma bond. Okay, so label the sigma bonds. It's very important to label the sigma bonds as well as the orbital. Okay, so hybrid orbital is sp3d, so label it. Now as you can see in the middle, because this image was taken from the internet, okay, this is the actually this is the correct hybrid orbitals, but for exam purpose you are not required to draw this little flower at the center here. Okay, you can leave it, you can omit it. Okay, you just have to show the normal way that you have been taught in tutorials. Okay, that's very important. Okay, you can leave out this part over here, right? And another one more thing that I want to highlight in this drawing is that make sure you have, because it's an ion, so make sure you have a square bracket with a positive charge for the diagram, and make sure to label for the terminal atoms as well. So you have fluorine, and the orbital that overlaps with the hybrid orbital is a 2p orbital. So make sure to label that as well. And this structure has got a lone pair on the central atom. So make sure the lone pair is shown. Okay, placed inside the sp3d orbital. Okay, and the point of overlap, make sure there is two pairs, a pair of electron there. All right. So this should be actually a half-headed arrow because this picture was from the internet. So they have put a full-headed arrow. Should be a half-headed arrow at the point of overlap. Okay. So I think there are many questions coming on in the chat box. So thank you to Madam Amiza and Dr. Yvonne in replying. Okay, so let's continue. So the next type of question that we are going to see under chapter 4 is compare and contrast questions. So for these compare and contrast questions, you are allowed to tabulate your answers. Okay, but remember, even though if you are tabulating your answers, you have to write complete sentences. Okay, when you are filling up your table, and make sure all key facts and correct terms are used. All right, so let's look at an example so that you have a clearer picture on what I'm saying. So in this question here, explain the difference in polarity between XO2 and XO3. All right, so for this, okay, so this is an answer, sample answer, as you can see over here. This question is actually the how do I say, it's actually the fourth question in a long question. So I just took it out to show you how students can write answers to get full marks. So what you can do is that you can tabulate your answer. As you can see inside the table, complete sentences are written. Okay, so don't just state AB3, bend shape, unsymmetrical. Okay, that is not a nice representation of your answers. Write complete sentences to get full marks. All right. So as you can see, this is comparative writing. As for the second one, bond dipoles cannot cancel each other. So the other one, it's written as bond dipoles can cancel each others because the question clearly says explain the difference. So you have to write it comparatively. Okay. And finally, regarding the polarity, you can write as such at the bottom, whereby XO2 is a polar molecule and XO3 is a non-polar molecule. Okay, so compare and contrast question, you can do it in the form of, you can tabulate your answers, no problem. Okay, and if you don't want to tabulate your answers also, you can, but write it comparatively. Okay, don't just write a chunk of XO, satu perengan XO2 dan satu lagi perengan XO3. No, that is not compare and contrast. I'm sure you have done this similar sort of things in English as well. So you have to write it comparatively. Okay, you cannot write a paragraph of XO2 and another paragraph of XO3. So that doesn't work. Okay, so the next type would be the explaining type questions. Okay, so here I've clearly stated that the length of your answer depends on the marks allocated. So always use the marks given in the question as a guide for you to write, because I see students, usually the feedback that I get, madam, berapa banyak nak tulis ni? You know, that kind of feedback. So how do you get a good guide on this is the marks allocated beside each question. That should be a good guide to begin with. So you can write it in point form, as I've shown in some examples before, but must use complete sentences. Do not use point forms and short forms together, okay, and short points. And again, use simple language. Okay, you don't have to be very bombastic. You just use simple language, but not short forms. Okay, intermolecular forces, for example, please do not write it as IMF. Okay, write it as intermolecular forces. Okay. Next would be to include all key facts and correct terms. This is very important in all the questions that you are answering. And also, I would definitely encourage you to have the habit of underlining the keywords in the question. Okay, to correctly identify what needs to be explained. This is a very good habit, and please do it. Okay, if you have a highlighter, if you have a colored pen, please do it. Please underline. It will really help you in tackling this kind of explanation and description questions. So we have an example over here. Now, explain the type of bonding formed in sodium metal. So this is a sample of wrong answer. So as you can see here, by reading first hand, you sort of feel that, this is a correct answer, but no. What is missing here? What is missing here is the key facts and the correct terms, as well as why we cannot grant a mark for this answer is the usage of short form. Okay. Yes, everyone understands E with a power, negative power is electron, but that is not how you answer an exam. Okay. So the correct answer would look something like this, whereby the key facts and the correct terms are all included in the answer. The electrostatic force of attraction between sodium cation and the C of delocalized valence electrons forms metallic bond in sodium metal. Okay, you have to write it in full. Okay, you have to include all the correct terms, no short forms, and all the key facts in answering explaining type questions. So this question is awarded 2 marks. Okay, explain the type of bonding formed in sodium metal. This question was awarded 2 marks. So for a 2-mark answer, this is sufficient, whereby you are clearly indicating the force of attraction. Okay, what force is it? It's the electrostatic force of attraction between who? The sodium cation and the C of delocalized valence electron. If you see the wrong answer, it's just stated here the force of attraction between positive ion and C of electron. This is not specific. Okay, so please make sure when you're explaining, when you're answering explaining type questions, you are very specific with your answer using the key facts and correct terms, and make sure you don't have any short forms used. Okay, so as a summary for chapter 4, right, the key concepts to master would be this. Okay, this is actually like a run through for you after you have finished your revision. So these are the things that you should focus again. Okay, look back into it again, make sure you have mastered it very well, like the Lewis dot symbol. Okay, what are the exceptions we have in the octet rule, the VSEPR theory. Please look into bond polarity and dipole moment. Sometimes you just pass through this, but this is also a key concept. Okay, questions can be asked. Hybridization, intermolecular forces. Okay, and focus on hydrogen bonding, which is on the effect on boiling point, solubility, density of water comparing to ice, as well as relationship between vapor pressure, boiling point, and intermolecular forces. And finally, as on metallic bond and the C electron C model. Okay, so I noticed that the last line is not visible, but never mind, I will post it up with some edits later, right? So let's go on to chapter 5. Okay, states of matter. So states of matter actually has got lesser weightage than the previous chapter that I discussed, but that does not mean this chapter is less of important. Okay, you want to score your A, you have to master all your chapters very well. So commonly asked questions under chapter 5 would be state defined questions. Yes, you will have it. You do have to sketch and label. Okay, classify and arrange questions are also present. Okay, you have questions on determine and predict, explaining as well as describing. But most importantly, calculation. As you can see, I have capitalized and bolded the word calculation over here because chapter 5 questions are very famous. The calculation type questions are very famous in chapter 5. So let's look at some of the mistakes students do under chapter 5. So by the first question on defining Boyle's law. So if a student A is giving me an answer like this, okay, it won't be accepted. I would mark it wrong. So student B writing full sentences with the correct terms will be awarded the mark. Okay, so this is for understanding purpose. Yes, this is correct, but not for definition. For definition, make sure to use the correct key terms, okay, and write a complete sentence. That's very important. Okay, even 1 mark is very important in your exam. So the next example, definition of boiling point. Okay, I'm sure this is a simple definition that you all remember, but this is not the definition that is in your lecture notes. Okay, so boiling point is the temperature at which liquid changes into vapor. No, that's not the correct and the specific definition for boiling point. You should actually say the temperature at which vapor pressure of the liquid equals to the atmospheric pressure. Okay, so again, these two examples are to highlight the importance of key words usage and correct term usage in your exam. Okay, so please take note of that. So as for the calculation questions, mostly it revolves around your ideal gas equation, okay, and also your gas laws as well as the van der Waals equation. So please don't forget about your van der Waals equation. So one key point that you must note is that you have to convert the variables to the correct unit. Okay, so for example, if R value is given, if you are using the R value as 0.08206 liter atmosphere per mole per Kelvin, so make sure your pressure is in ATM, your volume is in liter, which is the same as dm cube, okay, and temperature must be in Kelvin. So a failure to convert is where students make mistake. Okay, that's the common mistake that happens when we are marking exam papers. Students forget, or maybe how do I say students? Yeah, mostly students forget. I'm sure you all know. Mostly you forget to convert, and that makes you lose a lot of marks. So next on writing relationship type questions, describing and explanation questions, please write your answers in complete sentence. Okay, so this here with the arrows up and down, this is good for your understanding, this is good for your short notes, but not for exam. Yeah, okay, so for exam, a paragraph like this is very important, whereby as you can see, if you want to describe the relationship between vapor pressure and boiling point, you talk from this liquid having a strong intermolecular force and exerts a low vapor pressure. More energy is required to overcome the attractive forces between the molecules and more difficult to acquire vapor pressure that is equal to the atmospheric pressure. Thus, liquid boils at higher boiling point. So a complete answer like this is important. And yes, you don't have to use the same strong, lower, higher here. You can use synonyms to it. No problem. Okay. You make sure the meaning doesn't changes. That's what you need when you are writing explanation type question. You don't change the meaning, but you can use other words. Okay. You can change your sentences. Thus, this increases boiling point. Yes, can, no problem. It brings the same meaning, right? You don't have to bulat bulat, that's what we say in class. You don't have to bulat bulat write exactly, but understand it and write it with your own words. Make sure the meaning of your answer does not change. Okay, that's very important. So under chapter 5 also we have 5.4 phase diagram. So this is a question whereby you are required to either sketch or plot. Okay, a more common question would be on sketching, but if the question requires you to plot, remember you have to do it on a graph paper. Okay, graph paper usually will be provided for you. You can request for it, right? If it's a sketch question, you have to answer in your exam booklet. Okay, and make sure when you're drawing your phase diagram, you have your axis labeled correctly. Okay, please look through back, read it. Okay, make sure you have labeled the faces in between the lines and the curve correctly, and make sure to include all important data given in the question. Don't miss out. Okay, scoring for phase diagram is basically writing out all the important data given in the question. Okay, not missing out on labeling, as well as writing out the important data in the question, such as critical and triple point. So finally, okay, what you have to do is that you have to only use a pencil to plot or sketch the diagram. So please do not use a pen, right? Maybe you can use a pen for your axis, that's fine. But for sketching or plotting, okay, for plotting especially, use a pencil. Okay, for sketching the graph in the middle, please use a pencil, do not use a pen. Right, so please carry a 2B pencil to your exam. Right, the other questions, yes, you have to write it in pen. Please do not use pencil. You have to write it in pen, but for drawing purpose, please use a pencil. Okay, I'm going to show you an example of a fully drawn phase diagram for you to take note. As you can see here, the phase diagram is labeled with the title. Y-axis is labeled, x-axis is labeled together with the units. Okay, the phases are labeled, right? The triple point and the critical point is also labeled. Okay, it would be good if you can use dotted lines going down and going to the side over here, as I'm showing, to indicate the temperature and pressure for the triple point as well as the critical point, if data is given. Okay, or not, you can just label here as triple point and label this point here as critical point. Okay, label is very important. As you can see here, these are the ticks which gives you marks. Okay, so on a final note, these are the key concepts under chapter 5, which I have summarized in a table based on your learning objectives. So please read through this. Okay, if you are able to answer each of these key concepts, that means you have prepared well for your chapter 5. For example, if you are able to sketch and interpret graphs of Boyle's and Charles' law, give yourself a tick. Okay, this is how you prepare for your chapter 5. Okay, this will be online, so you can always come back and look at it, take a screenshot of it, right? And make a checklist. This is basically a checklist for yourself to master the concepts under chapter 5. Okay, right? So the last sentence here, as you can see under phase diagram, okay, it's actually pressure. Okay, so please take note of that. It's pressure bracket at constant temperature. Okay, the slide somehow has is not showing the last line, but it's okay. Pressure at constant temperature. All right. So with that, I'm ending my section for this live session today, and this will be continued with Dr. Ivan's session on chapter 6 and chapter 7. What are the key points? What are the things that you should note? Okay, so continue watching and thank you.
Okay. Madam Vansh?
Yes, Dr. Ivan, you can start presenting. Thank you.
Okay. Okay. Um, okay, good morning, everyone. Thank you for joining us once again. Okay, so my part, I will be discussing on chapter 6 and chapter 7. Okay, so we look on chapter 6 first, yeah? So the topic is chemical equilibrium. So in chapter 6, all right, the marks allocated for the question is 9 marks, all right? The questions allocated is 9 marks, all right? So what are the type of questions that can be asked in this chapter? Okay, so there are questions on definition, okay, explanation, of course, calculation, calculate or determine, okay, and also predict. Okay, so in the context of predicting the direction of a net reaction. Okay, all right. So I'll go through an example, okay, of question. Okay, so if we see this question, all right, this question, all right, sulfonyl chloride is a very reactive gas. It decomposes as follows when heated. Okay, so now you see, they may give you question, okay, like this, okay, in one paragraph like this, okay, or either, okay, they can even give you question in parts, okay, part 1, part 2, or part 3. So it depends, okay. So if questions are in parts like this, okay, it is easier for you to see very directly what is needed for you to answer. Okay, but if a question, okay, is put in a paragraph like this, so you should be highlighting what are the important points, or what are the important things that you would need to answer. Okay, so if you see in this question, the mass of SO2Cl2 is added to 1 liter container, temperature is elevated to 375. Okay, if the decomposition has not yet occurred, what is the initial pressure of in this container? So you see there is one question over here. What is the initial pressure in this container? So that is the first part. Okay, all right. And then as the system attains equilibrium at 375 Kelvin, the total pressure in the container is 1.43. Okay, calculate the partial pressures of the gases at equilibrium. So this is the second part of the question. So there are two important things that you need to find here. Okay, so very importantly to highlight, okay, to highlight information that is given to you in the question. Okay, you can highlight, or even you can extract and write it out. What are the information given? Okay, so here we will have a look at how you can present your answer, because most of you know how to get the correct answer. Okay, but how to write or present your answer may be still lacking. Okay, all right. So how you present your answer to get your marks. Okay, so calculation normally is a question where it uh, is quite easy to obtain marks for calculation question if you follow the method or way or the flow of writing, presenting your answers. Okay, so for this question, what you need to do is, of course, firstly, you need to find the moles. Okay, so all this should be shown. Okay, the moles, okay, mass over the molar mass. Okay, you write it, the mass over the molar mass, and you get the moles. So this, there will be marks for this. Okay, and then since this is the first part of the question that you need to answer, initial pressure in the container. Okay, so always has it has been stressed before this, you need to write the formula. Write the formula, substitute the value, and get the final answer with unit. Okay, so when you present your answer like this, okay, all the marks wherever is possible which is supposed to be given, you can get. Okay, so take note, yeah, calculation question especially. All right, so we are done with the first part, initial pressure in the container. Okay, the next part is they ask you to find the partial pressures of the gases at equilibrium. Okay, so to solve this question, this is where you would need to use the ICE table, initial change and equilibrium. Okay, so here also there will be marks given, okay, for the ICE table. Okay, most probably 2 to 3 marks depending. Okay, so clearly show what are the information that is needed in your table, okay, to find. All right, so all this you have done before, so it's not a problem actually. So just reminding you, okay, reminding you of how you should actually write your answers. So this is the information which is given in the question. Total pressure at equilibrium is 1.43 atm. Okay, so you have to equate it like this and get your x. Okay, so once you have got your x, then you can have your, you can answer as your partial pressure of SO2 and Cl2 is 0.6321 atm, and the partial, since this is x, yeah, and also the partial pressure of SO2 Cl2 will be 0.7979 minus x, so you will get this. Okay, so calculation question, write everything in detail. Okay, show all your working properly. Okay, so that you may get marks wherever it is. All right, okay, don't skip lah if possible. All right, so this is the part of the question. So once again, I stress here, if the questions are given part by part is fine, it's okay, it's easy for you to see. But if the question comes as a paragraph or a shorter paragraph, something like that, you would need to read carefully and highlight what is required of you to answer. Okay, should we go to the next one? Okay, this is the question to predict the direction. Okay, example that a question could be asked in this chapter. Okay, so the value of Kc for this reaction is given. Okay, a mixture of these gases is not at equilibrium, has the following concentrations. So in which direction? In which direction must the reaction proceed? So you will need to answer this question. Okay, in which direction must the reaction proceed? Okay, so right, so you would use, of course, in this question you would need to find Q, right, the reaction quotient. Okay, so write the expression. Okay, you will need to write the expression, there is marks for it. Okay, write the expression. Okay, and then substitution, substitute the concentration which is given to you. All right, and then finally you get your value of QC. Okay, all right, so here, in order to know which direction is the reaction proceeding to achieve equilibrium, Okay, then you would compare, isn't it? Q, you would compare with Kc. Okay, so state it clearly whether the Q is smaller than Kc or whether it's greater than Kc. Okay, so you state there it is smaller than Kc. Okay, so the reaction will proceed to the right to achieve equilibrium. So jawapan ini mesti menjawab lah. Okay, menjawab soalan yang ditanya ini. Which direction must the reaction proceed? Okay, all right. Okay, so another type of question. Okay, another type of question. All right. Carbon monoxide reacts with oxygen to produce carbon dioxide as follows. So you're given the equation over here. Okay, explain how the amount of CO2 could be increased. So you have to read the question carefully. Okay, explain how the amount of CO2. So CO2 here is your product, isn't it? So meaning that the direction that you want to go is to your right. Okay, so the question says here, explain. So you have to give the factors. For example, okay, you want to increase the amount of CO2, means that, okay, for example, here you have to add CO, carbon monoxide, or add oxygen. So you cannot just leave your answer with this, okay, because it is explaining. So you have to give some explanation to your factor that you have included. Okay, so adding CO2 or O2. So this, because of this, the equilibrium will shift to the right to reduce the reactant. Okay, and CO2 increases. Okay, so another option will be removing CO2. So you will always refer to what is the marks given in the question. Okay, what is the marks given in the question? Okay, so berdasarkan kepada markah, how many points maybe that you can give. Okay, so removing CO2, for example. Okay, so you remove CO2 means the equilibrium will shift to the right to increase CO2. Right? Okay, and then you may also want to give in terms of volume or pressure. Okay, decreasing volume or increasing pressure. Okay, so explain, remember, so you have to give some explanation. So why? What will happen? So the reaction will shift to the direction of lower moles of gases. Okay, so therefore the reaction will shift to the right and CO2 increases. Okay, and then these are all the possible answers, yeah? So these are possible answers to increase the amount of CO2. And then you may also want to include temperature. Okay, so decreasing temperature is one of the factors. So when you decrease the temperature, the reaction favors an exothermic process and will shift to the right to release heat and CO2 increases. Okay, so this is a question of giving the factors, okay, of how. Okay, so the factors in terms of concentration, volume, temperature, okay, volume or pressure and temperature. Okay, so you have to read the question carefully. Okay, so chapter 6, okay, these are some examples that I've given. All right, now we'll go on to chapter 7. Okay, now chapter 7, the allocation of marks is 14. Okay, 14 marks. Okay, so the type of questions that they may ask in this chapter would be, okay, definition. Okay, same thing, we have definitions, we have explanations, calculate. Okay, sketch. Okay, sketch in the context of this chapter, chapter 7, okay, it would be a sketch of sketching a titration curve. Okay, sketching titration curve. Okay, and untuk soalan jenis predict, okay, most probably, okay, it's about predicting the possibility of precipitation. Okay, dalam bahagian solubility, equilibrium. Okay. Okay. So now let's look at an example of question. Huh? All right. Okay. So beginning of this chapter, we learned about acid-base conjugate pairs. Okay. As we said, you all know the answer, but how do we write it in order that you do not lose marks? Okay. Knowing the answer is not enough. Okay. But how you write it, always remember that. Okay, so you have this reaction here. So to identify the acid-base conjugate pairs. Okay, so you identify the acid. So you show the pair, which is the conjugate base. Okay, and then this is the base and this is the conjugate acid. So the conjugate pairs must be shown in pairs, of course, they are in pairs. Okay, all right. Let's look at another example. Okay, this question. Okay, so here once again, the question may give you in parts 1, 2, 3, and so on, or either just one piece of information like this. Okay, so whatever it is, you need to highlight and know what is given in the question and what you need to find. Okay, here you will see at 25 degrees, 2.20% of 0.125 molar benzoic acid ionized. Write the ionization equation. Okay, write the ionization equation for benzoic acid in water. So this is one. Okay, this is one part. Of course, you will be writing it, isn't it? So, and then determine the acid ionization constant. Ini bahagian yang kedua. Okay, and then calculate its pH. Ini bahagiannya ketiga. So all this must be answered. Okay, so now you are calculating Ka. Benzoic acid is a weak acid. Okay, so for this chapter, mostly calculations dealt with weak acid or weak bases. Okay, mestilah menggunakan arrow reversible. Okay, because there will be marks for your equation. Okay, so you kena pastikan arrow ini betul. Right, reversible arrow. And you will also need to include the phase. Right, include the phase. So this question can be solved by using the, of course, the table, initial change and final. Okay, where you have the initial concentrations of the acid, okay, and then the change. Okay, so here the information of the percent ionization is given to you. Okay, so you know the percent ionization equals to the change, the X over C, correct? So by substituting the values in here, you boleh cari nilai X. Okay, so your X will be the ionization, okay, times with the concentration. Okay, so this one you can see on your own. So this is just showing you how, okay, you systematically answer your questions like this. Okay, and then you have a final concentration. All right, so Ka, okay, to write your Ka. So Ka expression must be written. Don't forget, okay, for Ka, we do not include liquids and solids into the expression. Okay, so you have to write the expression Ka, substitute the value, okay, substitute the value and get the answer. So remember, yeah, Ka, there is no unit. Okay, in our syllabus, Ka, Kb, okay, doesn't have unit. Okay, so you just leave your answer without unit. Okay, then you have to do the pH. So this is all formula, put in your value and get your answer. So pH normally we can leave to 2 decimal places. All right. Okay, now question like buffer. Okay, question like buffer solution. Okay, define buffer solution. 1 minute, yeah. Okay, define buffer solution. Sure. Wait. Okay, so for defining buffer solution, this question, so we have the definition, a buffer solution of which the pH does not change significantly on the addition of a small amount of strong acid and strong base. So definitions must be complete. Okay, definitions must be in complete sentence. Okay, and then the second part, explain how the pH of a mixture of aqueous ammonium chloride and aqueous ammonia, sorry, yeah, this has to be ammonia. Okay, explain how the pH of a mixture of aqueous ammonium chloride and aqueous ammonia remains constant when a small amount of strong base is added. Give suitable equations in your explanation. Okay, so Alan ini asking you to explain how the pH of the solution which contains ammonia and ammonium chloride, okay, remains constant. So here class, what you do is, of course here dalam soalan ini they are given to you, give suitable equation in your explanation. Okay, but even katakan statement ini tidak diberikan, okay, so you already know for buffer systems, we explain based on equations, correct or not? Okay, we explain based on equations. So, okay, so you may write the equations, okay, untuk salt, this is the salt of ammonium chloride which dissociates fully, right, in water. And then the ammonia, which is the weak base, dissociates partially. Can you see dissociate partially? We use a reversible arrow. Okay. And then when a small amount of strong base is added, okay, this equilibrium will shift to the left. Okay, meaning that the ammonium ions, okay, remove or neutralizes all of the added hydroxide ion. Okay, so the hydroxide ions are neutralized by the conjugate acid, okay, to produce. So this is the equation. Okay, so as a result, the pH remain constant. Okay, so buffer solutions or buffer system needs to be explained based on equations. Okay, need to be explained based on equations, right? Okay. Okay, then I will go into the next one, which is titration. Okay, titration. Okay, so here the question says differentiate between endpoint and equivalent point. Okay, so what you can do, you can also do a table. Doesn't matter, you want to put it in a table, what is endpoint or what is equivalent point also can, or either you can just answer it like this, it's fine. Okay, now so endpoint, you all know, is the point which the indicator changes color. Okay, the equivalent point is the point at which the amount of acid and base present exactly neutralizes one another according to the stoichiometry. Okay, so actually this question, something similar to what we're actually defining lah. Okay, okay, but they have put it in the term of differentiate. Okay, all right. And then, okay, let's have a look at this question. Now, this is where the part of sketch a titration curve comes in. Okay, sketch a titration curve. Okay, so this is a titration between 25 ml, 1 molar ammonia with 0.25 molar HCl. Okay, so you look at the question, you have to indicate the pH corresponding to the equivalence point. Okay, and you have to classify the salt formed from the titration. Okay, so in order for you to sketch a titration curve, so a titration curve, okay, as whether you draw a graph or you draw a curve or whatever it is, you have to label, okay, your axis has to be labeled correctly. Okay, this is pH. Okay, and here should be the volume of titrant. So you need to read carefully in the question. What is the titrant that is used here? Okay, so maybe you can sketch for yourself. Okay, you can sketch for yourself and see here. Okay, so the titration is between 25 ml volume and concentration of ammonia. So this is going to be in your conical flask. Okay, volume of 25 ml and concentration of 1 molar. This is ammonia. So what is going to be in the burette, okay, which is your titrant, is the HCl 0.25 molar. Okay, so when you are able to identify what is in your conical flask and what is in your burette, then only you will know which kind of a curve you will get, whether it's going up, down, or whether it's going from down to up. Okay, so here, before the addition of HCl, you have ammonia, which is the weak base. Okay, you have ammonia in the conical flask. So when the volume of HCl here is 0, this is a base, meaning that you are going to start your titration curve from the top. Okay, from the top. Okay, so your curve, all right. Okay. Okay, maybe something like this. Okay, or maybe you can, okay, draw it a bit better, of course. Okay. Okay, so okay, all right. So here you need to identify the pH at corresponding at the equivalent point, corresponding to the equivalent point. Okay, so what is the type of titration here? What is the type of titration here? It is between a strong acid and a weak base. So the pH at equivalent point, okay, will be acidic, correct or not? pH will be less than 7. Okay, so you have to show on the titration curve. Just say, for example, here, okay, that this is the pH less than 7 and it is the equivalence point. Okay, and another thing is you will also need to indicate what is the volume of the titrant. What is the volume of the titrant? Okay, now to find what is the volume of the titrant is at equivalent point. Okay, you can use the formula MAVA equals to MBVB, correct? Because the titration is between ammonia and HCl. So the ratio is 1:1. Okay, so because the volume and the concentrations are the same, therefore the volume of the acid will be the same. Okay, 1 and 25 ml. Okay, so This is 0.25 and this is, oh, okay, sorry, yeah. This one, the concentration is 1 molar, 1 molar, 25 ml. Here is 0.25. So your volume of the acid will be 100 ml. Okay, 100 ml. Okay, 25, 0.25 concentration of the acid. We want to find the volume. Molarity of the base is 1 and 25 ml. So your volume is 100 ml. Okay. And one more thing that you may want to check, okay, you may want to check is when you draw this titration curve, okay, this is a titration between a strong acid and a weak base. Okay. So the end point pH range, okay, for titration, strong acid and weak base is 3 to 7. So that will give you a guideline. So lebih kurang 3 to 7 is where you have the steep part of your titration curve. Okay, titration curve. Not necessary to label the 3 over here, tapi just for your reference. Okay, just for your reference. So this is how you would sketch a titration curve. Okay, the things that you would need to consider. Okay, yang penting juga you need to understand this. Okay, so pH versus volume of HCl. Make sure you have your pH here indicated, pH less than 7. Okay, equivalent point. And then you need to answer, you need to classify the salt. So what will be the property of the salt? It will be acidic, of course, with pH less than 7. Okay, with pH less than 7. Okay, so these are questions on titration, example of question. And final question is on solubility equilibria. Okay, so this part is okay, about solubility of salts. Okay, the solubility of salts. So here in this question, okay, so you may have done this question before, not a problem. Okay, so the solubility product KSP of silver sulfate is given. Okay, there's a mistake here. Okay, there should be 2 here. Okay, Ag2, there should be Ag2 over here. All right, so 1.5 and 10 to the power of minus 5. Calculate the molar solubility of the salt in distilled water and in 1 molar sulfuric acid solution. Okay, so to calculate the molar solubility, okay, you can leave an X molar. Okay, so always when you are using a X or a Y or an unknown, okay, so you must define it. Okay, kena define. Okay, jangan terus guna X, Y in the question. Okay, so as I said, this is how you need to write. So X will be the molar solubility of silver sulfate in water. Okay, so equations, all these phases must be written. Okay, the phases of the species must be written, and please take note because these are salts which are slightly soluble. So we will use the reversible arrows. Okay, and then write the expression KSP. Okay, write the expression KSP, and then put in your values and you get the answer. All right, molar must have the unit, yeah, must have the unit. Okay, and then if you want to calculate the molar solubility of silver sulfate in 1 molar H2SO4 solution, so you will let Y molar. Okay, define it also, molar solubility of silver sulfate Okay, then equation. Okay, you have done this before, so please take note. Yeah, all your faces are important. All right, and then you can do an assumption over here. Okay, assuming that the value of y is small, so it makes your calculation much easier, and you will get to the final answer. Okay, so this is how. Okay, so most of you may have done all these calculations and so on. So it is a reminder that is very important on how you present your answers. Okay, how you write. You must always remember that the examiners do not know anything. Okay, that was advice given by my teacher before. Okay, you have to think that the examiners don't know anything. So when you write, present your work as clearly as possible. Okay, supaya jelas. Okay, dia boleh faham, it's very neatly presented. Okay, step by step. Okay, so I think for chapter 7, that is all for chapter 7. Okay, so right. So 1 minute, yeah, just 1 minute. So I am not sure how you all are actually feeling. Okay, how are y'all feeling for as you get prepared for PSPM, because this is a very, very different scenario. Okay, during the pandemic now. So some of you may be happy. Okay, some of you may be happy. Oh, I'm happy to sit for the exam because I'm well prepared. Okay, some of you may be stressed. Okay, some of you may be stressed. Okay, that is normal. Okay, nervous. Okay, so these are some of the emotions that you may have. Okay, worried. Okay, because as I said, all of us is experiencing a different norma baru sekarang, ya. We have been learning online for some time, and you may not be able to get as much as what you're getting through face-to-face lessons. Okay, so this is something normal. All right, so just a few things. How do you prepare yourself? Okay, besides of course answering your papers properly and writing your answers well and so on. Okay, so please remember, you need to get enough sleep. Okay, before your exam. Okay, you need to get enough sleep. So you don't want to be sitting in the examination hall feeling sleepy and cannot focus on what you're supposed to on the questions. Okay, and then you're supposed to eat the right food for exam. Okay, you have supposed to eat. Okay, your examination time, no matter for what paper. So for example, chemistry, 2 hours paper. Okay, is the 2 hours is very crucial, sangat penting 2 jam itu. Okay, so you must be very comfortable. Okay, so before you sit for your paper, okay, jaga apa yang you makan supaya you don't want any stomach upset, you don't want to feel uncomfortable masa tu, betul tak? Okay, alright, so you have to basically take care of your health. Okay, your health is very important. Okay, especially when you sit for examination. And sekarang ni masa pandemic ni, so I hope you all will take good care of yourself. So your exam is just around the corner, right? And you also have to keep calm and do not stress. Okay, you shouldn't be stressing yourself. Okay, because when you stress up, you cannot think. You tak boleh fikir. Okay, so being calm is very important. Okay, because if you are stressed, you are not calm, tak tenang, apa yang anda boleh ingat pun anda akan lupa. Okay, so please try to keep yourself calm. Okay, do not stress up. Okay, so and then you have to keep a positive attitude. Attitude ataupun spirit. Attitude is very, very important. Okay, you have to keep a positive attitude that no matter what, okay, I'm going to do my best. Saya akan buat yang terbaik. Okay, I will do my best. Right, the positive attitude is very important. Okay, and then also you need to talk to someone who can encourage you. Okay, you need to talk to someone who can encourage you. Jangan pendam, jangan simpan. Okay, you feel stressed up, you feel like talking to somebody, call your lecturers, call and speak to them, ataupun your parents or your friends. Okay, let somebody encourage you, because sometimes we need those kinds of encouragement, especially before exam. Okay, all right. Okay, so remember, you have to believe in yourself. Okay, and all that you know, that there is something inside you greater than any obstacles. So we have to, kita kena belajar macam mana nak adapt, how to adapt to situation. Itu yang penting. That is a successful person. Okay, apa obstacle yang datang pun kita cuba adapt and we try to go with it. Okay, so yang penting, now we have about 1 week to 2 weeks before your PSPM. This time is really crucial. If you really make use of it wisely, okay, you can do wonders. Okay, miracles boleh happen. Okay, so the best preparation for tomorrow, you must do your best today. So just now I stress banyak kali on attitude. Okay, why do I say attitude is very important? So this is a small truth. You may have seen this before. A small truth to make life 100%. Okay, so kita semua tahu abjad ini ada nombor A sampai Z, boleh jadikan 1 sampai nombor 26. Okay, so when you take hard work, you add on all the alphabets punya number, you get 98%. Okay, knowledge, you get 96%, which is important. Definitely it is important. Okay, and then love, 54%, luck, 47%. So don't based on luck or whatever, you think most people think that this is important, but actually it's so percentage sangat rendah. Okay, all right, and then so then what makes 100%? Money? No, 72%. Leadership is 89%. So that is out of the question. Okay, so every problem has a solution only if we change our attitude. So why do we say talking so much about attitude? Because the attitude makes 100%. Okay, the attitude makes 100%. So it is our attitude towards life and work, and especially now in your studies, that makes life 100%. So what you need to do, attitude is everything. Okay, attitude is everything. Change your attitude. Okay, 2 minggu ni apa yang actually banyak boleh buat dalam 2 minggu ni juga. If you use your time wisely. Okay, so change your attitude. Okay, be motivated. All right, be motivated, stay positive, and always believe you can do your best. Okay, so that is all from me. Okay, thank you, and wish you all the best kepada semua pelajar KMPK, all the best for PSPM, from all of us chemistry lecturers at chemistry unit of KMPK. Okay, thank you very much.
Okay, thank you, Dr. Yvonne. Okay, right. So we are not done yet. I have some information to pass to you. So hold on, yeah. Just trying to set. Yeah. Okay. Okay, so thank you so much for your participation today. We are close to 2 hours actually today. Okay, so thank you for all your participation. It's actually our first time doing live, and support that we are receiving from all you students is very, very encouraging. Like, we have a very interactive chat box, so thank you for that. Okay, we really hope that from Unit Kimia, it was a very fruitful session and you have benefited a lot from it. Okay, especially on the insights of each chapter. And I would also like to take this opportunity to apologize if there was any shortcomings from our side, especially on the technical issues and all. So we hope and we look forward to conducting more live sessions after this, and we definitely encourage your full participation. Okay, so this video will be on YouTube, so you can always replay it and watch whichever part that you have missed. And what's coming up next is actually a quizzes live challenge. There has been advertisements going on. It's going to start at 11:30, and it's going to be for 1 hour. So it will be a good platform for you to actually test all your knowledge, because it will be based on your syllabus. And on top of it, it's not only for testing your knowledge, and you're also going to win prizes and certificates. Okay, if you're the top scorers in the quiz. So look forward to it. There's about 45 minutes for you to prepare. So I hope all of you, those who are watching, will be participating in the quizzes live challenge after this. Okay, so that's all from three of us, me, Madam Vaish, Dr. Yvonne, and Madam Amiza. Thank you and have a great day.